Welcome to the Praxis Core Math, Module 1, Numbers and Quantity. Subjects covered in this module will include numbers and number parts, fractions, decimals, and percentages, mathematical operations, radicals, integers, and exponents, ratios and proportions, and quantitative problem solving. On the Praxis core, the only types of numbers given will be real numbers. Real numbers can be categorized into one of two groups, rational and irrational. Here are the different groups that make up the rational numbers. Natural numbers, also called counting numbers, whole numbers, natural numbers, and zero, integers, whole numbers, zero, and their negatives, and fractions, number parts that have a decimal with a clear end or a decimal with a repeating pattern. Rational and irrational numbers. Irrational numbers are numbers that, when expressed in decimal form, have no repeating pattern and never end. The most common example of an irrational number is pi, a number that starts with 3.14, but that has numbers after the decimal point that go on forever without a repeating pattern. So far, over 1 million digits of pi have been identified, and it just keeps going. Other examples are radicals of non-perfect squares, like the square root of 2, the square root of 3, or the square root of 12. Even though the square root of 12 can be simplified to 2 on the square root of 3, it doesn't simplify to an integer in the way that the square root of 16 simplifies to be 4. If a number that is in a fractional form contains an irrational number, then the number is irrational. For example, pi over 2 would be irrational because it contains pi. Mathematical operations. Addition is the process of combining values. Subtraction is the process of taking away values. One of the most important things to remember is that addition and subtraction are inverse operations. One undoes the other. While this may seem simple, it will be very important when we begin manipulating equations. Multiplication is the process of repeated addition of a set value. Division is the process of separating numbers into groups with a set value. Multiplication and division are also inverse operations. Quantitative problem solving. Quantitative problem solving deals with applying mathematical reasoning to real-world situations. One of the most important aspects of quantitative problem solving is finding the math in the problem. At TLC, we use the focus method to help with this. The focus method consists of 5 parts. We first identify the facts, then the outcome, then the calculation, followed by the understanding and the solution. When looking at the facts, we ask the question, what factual information does this problem give us that we will need? Underline, take notes, or in some way determine what facts you have. For the outcome, we look at what information does the problem want to know? What units should we use in our answer? For calculation, we ask, what type of calculation do we need to do to solve this problem? For understanding, we stop and reflect. Is the number that I came up with logical? Does this actually make sense in the real-world context of the problem? You can catch many errors by asking this question. Finally, we look at our solution. Did we express the solution in the simplest possible form, and did we use the correct units as indicated by the problem? Consider the following problem. A hotel offers a multi-night rate of $75 per night for guests staying 3 or more nights. Bernice booked 2 nights and paid them at the full price rate of $90 per night. She then extended her stay by an additional 3 nights. If her entire stay now qualifies for the multi-night discount, how much would Bernice owe the hotel at the end of her stay? Pause the video for a moment and determine what facts the problem gives, what outcome the problem wants, what calculations you will need to do to arrive at that outcome. Take notes and then resume the video. You should have noted that the multi-night rate is $75 per night for guests staying 3 or more nights. You should also note that Bernice booked 2 nights and paid the full price rate of $90 per night for each of those 2 nights. The outcome that we want is to know how much Bernice owes the hotel at the end of her stay. The amount Bernice has already paid would be calculated by multiplying $90 times 2 nights to give us $180. The amount Bernice should pay for her whole trip would be $75 times 5 nights, which would equal $375. The amount Bernice should pay, $375, subtracted from the amount she has already paid, $180, would give us $195 as her remaining balance. Understanding, is $195 a reasonable amount to pay for a hotel stay? Then yes, Bernice owes the hotel $195. Consider the following problem. Miss Donna, the school custodian, always orders 1 roll of bathroom tissue per 5 students enrolled in her school. Currently, there are 500 students enrolled. She also keeps a reserve supply that equals 1/2 of her regular monthly order. Bathroom tissue comes in cases of 50 rolls, and it is impossible to order a partial case. If Ms. Donna is ordering for the first month of school, how many cases would she have to order to meet her minimum on-hand requirements? Look at the table. First, we identified the factual information that we would need to solve the problem. Then, we identified our desired outcome, the number of cases Ms. Donna would need. Next, we did our calculations. We calculated the number of rolls per student. We calculated how many rolls she would need for her reserve supply, and then we determined how many total rolls of tissue we would need. But remember, the problem didn't ask us for the number of rolls. It asked us for the number of cases. So our final calculation determined how many cases we would have to order to cover the number of rolls required. Finally, we ask ourselves, is 3 cases of paper a sensible answer for a custodian to order for a school? And of course it is. So our solution is that Miss Donna must order 3 cases of paper for the beginning of school. Many problems can be solved in multiple ways, but when you are working on a timed test, it's important to remember that you need to solve problems in the most efficient way possible. One of the ways to do this is to use order of operations and algebraic thinking to your advantage. Learn to identify keywords in the problem that can guide your choice of operations and utilize the most efficient problem-solving method possible. Some problems will require multiple steps, so remember to identify the steps in the process before you begin the problem. Consider the following problem. At a vegetable stand, Darrell bought 10 ears of corn for 65 cents each, 8 carrots for 40 cents each, and 5 broccoli crowns for 33 cents each, and a bag of potatoes for $4. What was the total cost for these purchases? One way we can find the answer would be to repeatedly add the dollar amounts for each of the vegetables. However, this is not the most efficient way to solve the problem. A faster way would be to multiply the numbers of each vegetable by their individual cost and add those products together. In a multi-step problem, it's important to identify the steps required to arrive at your answer. Consider the following. The city spent 28% of the $15,400 budgeted amount for trimming trees near power lines. How much of the budgeted money for trimming trees was not spent? First, we need to find out how much of the budget was spent. The word of means multiply, so we have 0.28 multiplied by 15,400, which tells us that $4,312 was spent. Next, we must subtract this from the budget to find out how much remains, or what was not spent. 15,400 minus 4,312 leaves us $11,088. Notice that this problem required 2 steps to complete successfully. There are 3 ways that we express numbers that are less than 1: fractions, decimals, and percentages. Fractions are numbers that express a part in relationship to a whole. The bottom number, or denominator, shows the number of parts into which the whole has been divided, in this case 4. The top number, or numerator, shows how many parts you are dealing with in a given situation, in this case 1 part per person. To express the amount each person gets as a fraction, you would say that each person gets 1/4 of the whole. Note, a fraction always shows a part of a whole and is always less than 1. Numbers that have an integer, whole number, and a fraction are called mixed numbers. For example, 2 1/4, if expressed visually, would look like this. If these were pies, I would have 2 whole pies and 1/4, or 1 part out of 4, of the third pie. Remember that a fraction is always less than 1. A fraction that has a numerator greater than its denominator is referred to as an improper fraction. Let's say that you had a pizza that was being divided into 4 parts, so your denominator was 4. Then, a friend showed up with more pizzas, and you ended up eating way more than your original 1/4. In fact, you ate your 1/4 of the first pizza plus a whole additional pizza, 5 out of 4 pieces. We might express the amount of pizza you ate as 5/4 of a pizza, or as 1 1/4 pizzas. To convert an improper fraction to a mixed number, divide the numerator by the denominator and place the remainder over the denominator. 5 1/4 would be 1 with a remainder of 1, so 5 1/4 would become 1 1/4. To convert mixed numbers into improper fractions, multiply the integer, whole number, by the denominator and add the result to the numerator. The denominator will be the same. To convert 1 1/4 into an improper fraction, multiply the denominator and the integer, 4 times 1, which would equal 4. Then add the numerator, 4 plus 1, which would equal 5, and place it over the original denominator, giving you 5/4. Multiplying and dividing fractions. To multiply 2 fractions together, Multiply straight across. This means to multiply the numerator of the first fraction by the numerator of the second fraction, and multiply the denominator of the first fraction by the denominator of the second fraction. To divide one fraction by another, flip the second fraction and then multiply. Adding and subtracting fractions. Remember, with fractions you are expressing a part of a whole, so there is no difference between saying I have 1/3 of a pizza or 2/6 of a pizza, because I would still end up with the same amount of pizza, just cut into more slices. The important thing to remember is that if you do something to the denominator, you must do the same thing to the numerator, so that the actual amount remains the same. To add or subtract fractions from one another, we must first make the denominator the same. This is called finding a common denominator. 1/3 plus 2/5 is a good problem to look at as an example. To find a common denominator, you must find the least common multiple of the two numbers. A multiple is a number multiplied by another number. In this case, the multiples of 3 are 3, 6, 9, 12, and 15. The multiples of 5 are 5, 10, and 15. The least common multiple of 3 and 5 is 15. It is important to note that while in this instance the numbers are multiplied by each other, that will not always be the case. Remember to look for the least common multiple of both numbers. This will keep you from having to go through additional steps to simplify at the end of your work. We know that the common denominator of 3 and 5 is 15, but remember that you must multiply the top and bottom number by the same thing to keep the actual amount the same. To make the common denominator 15, I had to multiply 3, the denominator, by 5. That means that I will need to do the same thing to the numerator. Likewise, I had to multiply 5 by 3, so that means I will need to do the same thing to the numerator in this instance as well. Now that we have a common denominator, we can add or subtract the two fractions. To do this, we add or subtract the numerators and keep the denominator the same. Decimals. Decimals are numbers that use place value to show amounts less than 1. One of the limitations of decimals is that they are only able to express numbers in which the denominator is a multiple of 10. The decimal 0.1, if expressed as a fraction, would be 1/10. Therefore, the first decimal place is referred to as the tenths place. The decimal 0.25 would be 25 over 100, since the 5 is in the hundredths place. The decimal 0.025 would be expressed as the fraction 25 over 1000, since the 5 is in the thousandths place. Currency is a useful tool to think about when considering decimals and fractions. Think of how 4 quarters make $1 and 2 quarters make 50 cents. Operations with decimals. Operations with decimals are simple because there is no need to find a common denominator. Decimal numbers are always an expression of a number as it relates to a multiple of 10. Decimals are easily computed using a calculator, but if you wish to work a decimal problem by hand, it is important to remember to line up the decimals and to express the numbers using the same number of digits by adding zeros as placeholders to the end if necessary. Percentages. Like decimals and fractions, percentage expresses a number that is less than 1. Percentages are based on the decimal system, so a percentage is an amount out of 100. To convert a decimal into a percentage, we must multiply the decimal by 100, moving the decimal point 2 places to the right. One of the most common usage of percents is to express change in price. If I had a shirt that originally cost $97.45 and I had a coupon for 15% off, how would I calculate the price of the shirt? To find this, I would need to go through a 3-step process. First, take the 15% and convert it into a decimal, 0.15. Second, multiply 0.15 by the price of the shirt, $97.45, to determine 15% of the original amount, which is $14.62. Next, I would subtract the percentage off from the total price. In this case, subtract $14.62 from $97.45 for a final price of $82.83. This type of problem would work the same way if you needed to add a percentage. Let's say sales tax was 8%. I would multiply my final price, $82.83, by 0.08, and I would find that the sales tax is $6.63. Then I would add this $6.63 to the price to get my final total of $89.46. Some percentage problems do not give the percentage. If the percentage is not given, it's a percent change problem. For example, I had $450 in my bank account, but I had to pay a bill and my balance is now $387. What is the percent change in the amount I had in my account? To do this, there's a very helpful formula you can learn. Percent change equals final minus initial divided by initial multiplied by 100. In the example, 450 is the initial and 387 is the final. Plugging in the values given, we have this equation. Note, when plugging in a problem like this into your calculator, it is imperative that you either do the math in the numerator first or put the numerator in parentheses. So we see that 387 minus 450 divided by 450 and multiplied by 100 equals negative 14%. If the percent is stated in the problem, then it is a percent increase or decrease problem. A pair of jeans was originally $40, but the jeans were on sale for 15% off and tax is 8%. How much do we pay? While we can go through the 3 steps mentioned and work it out by hand, there is a formula that will help us arrive at the answer much faster. The formula we can use for problems like this is a variation of the percent change formula. Final equals initial multiplied by 1 plus or minus the percent in decimal form. We'll use addition for the percentages that increase our number and subtraction for the percentages that decrease the number. Sales, coupons, and discounts cause decrease. Tax, markups, and tips result in an increase. Therefore, the final price of my jeans would equal 40 multiplied by 1 minus 0.15 multiplied by 1 plus 0.08. The initial price of the jeans was $40. We use minus for the sale and plus for the tax. For these problems, we can use additional sets of parentheses as needed for however many percent increases or decreases may occur. Thus, the final price of my jeans would equal $40 times 0.85 times 1.08 for a final price of $36.72. We understand that multiplication is done by repeatedly adding a set value. For example, 8 times 3 means that I would add 8 3 times to get 24. Exponentiation, the process of raising a number to an exponent, is very similar, but instead of adding a number, you multiply a number by itself the number of times indicated in the exponent. An exponent is written as a superscript beside a number. When a number has an exponent, the number is referred to as the base. If I write 2 with a superscript 3 beside it, that means that I am writing 2 with an exponent of 3. This is read as 2 to the third power. What it means is that I should take the 2 and multiply it by itself 3 times. Remember how addition and subtraction are inverse operations, and multiplication and division are inverse operations? In math, almost every operation has an opposite or inverse. This is also true of exponents. The opposite of an exponent is called a root, which is indicated by placing a number, the radicand, under the radical. While an exponent tells you to multiply a number by itself a certain number of times, a root does the opposite. It asks, what number, when multiplied by itself a given number of times, would give you the number under the radical? A number under a radical with no number beside it is considered a square root. That means that some number has been multiplied by itself one time to give you the number that is under the root. For example, the square root of 64 is 8, because 8 times 8 equals 64. This would be expressed as 64 under the radical, which would equal 8. Not all roots are square. To show that you wish to take a different root of a radicand, you can use an index, a superscript that is placed above the radical. Consider the following example. When I place the 3 above the radical and 512 under the radical, this indicates that some number multiplied by itself 3 times will give you 512. In this case, the third root, also called the cube root of 512, is 8, because 8 multiplied by itself 3 times will give you 512. Exponent rules. Rule for applying exponents to real numbers. Multiply the real number by itself. 2 raised to the third power equals 2 times 2 times 2, which equals 8. Rule for adding or subtracting exponents. Combine like terms. Like terms must have the same variable raised to the same exponent. You'll notice in the example, 3x squared plus 2x squared plus 9y to the third equals 5x squared plus 9y to the third. In this example, 3x squared plus 2x squared could be combined because they are like terms. They have the same variable raised to the same exponent. Rule for multiplying exponents. Multiply the coefficient and add the exponents. Remember that the coefficient is the number that comes before the variable. Rule for dividing exponents. Divide the coefficient and subtract the exponents. Finally, the rule for raising an exponent to an exponent. Apply the exponent to the coefficient and multiply the exponents. Rule for negative exponents. Flip the exponent to the other side of the fraction and make it positive. Remember that all whole numbers can be expressed as the number over 1, so even when they aren't written as a fraction, they can be expressed as a fraction. For example, the number 4 can be expressed as 4 over 1. If you have a negative exponent, you flip it to become the numerator and make it positive. Then you take the base and make it the denominator. Rule for the exponent of 0. Anything raised to a power of 0 is equal to 1. Rule for exponent of 1. A power of 1 doesn't change anything. This makes sense if we think about it. Exponents are repeated multiplication, and a power of 1 simply means that there is no repetition. Rule for 1 raised to a power. 1 raised to any power is still equal to 1. This makes sense because 1 multiplied by itself any number of times is always going to remain 1. Rule for exponents applied to binomials. Multiply the entire expression by itself. One of the most common errors with this rule is when people attempt to distribute the exponent. This is incorrect. Remember, multiply the entire expression by itself as you see in the example. This is one of the most commonly missed questions as it relates to exponents, so take a moment to review this carefully. Ratios and proportions. A ratio is a comparison between two numbers. We use these in real life every day, but we may not know to call them ratios. Consider a person who makes $1,200 per week, or a person who is driving 65 miles per hour. Could you tell me how much this person makes in a year? Could you tell me how far they might drive in an 8-hour day? You can, because you understand that the numbers move in a predictable way. This is a ratio. There are 3 ways we can write a ratio. We can write a ratio by using the word to, by using a colon, or by using a fraction. Let's say that we have a bag containing 3 blue balls and 2 white balls. Let's write out the ratio of blue balls to white balls. We can write it in 3 different ways. We can write 3 to 2, 3:2, or 3 over 2. Note, when 2 parts of a ratio are stated, there is an implied total that can be found by adding the parts of the ratio. For example, if you consider the situation above, the ratio of white balls to the total number of balls would be 2 to 5. While a ratio deals with one set of numbers that relate to one another in a predictable way, a proportion deals with 2 or more sets of numbers that move together in a predictable way. Again, these are things we use every day, even if we don't call them proportions. Consider the following situation. Susie is baking a cake. The recipe that she's following calls for 2 eggs for each cup of flour. If Susie has 4 cups of flour and wants to use them all, how many eggs does she need to bake her cake? To calculate this, we would use a proportion. Recall that a proportion is simply a statement that 2 ratios are equal. Our ratios are as follows. Eggs in recipe to flour in recipe equals eggs Susie has to Susie's flour. Plugging in our known and unknown values gives us 2 over 1 equals x over 4. Then we need only to cross multiply and divide to find 1x equals 4 times 2, which simplifies to x equals 8. Thank you for joining us for the Praxis Core Math Module 1, Numbers and Quantity. For additional math modules, please visit our YouTube channel.